We're
just
recording, by the way.
start module rec because we're probably going to need. Actually, no. Let's just do type
So now let's
equals.
open
We're gonna do a signature.
abstract,
Why
abstract.
would I want to commit a sin? Not this.
So which one you want to start with,
So
Marinho, about the abstract format? I was kind of thinking of
atom
functions.
string type var equals a
Functions.
string
Uh,
All right,
type
we should.
neutral
There's another link
equals
there. I should open the
open
documentation actually because where is Erlang
integer
abstract? Oh, I
of
already have a
int
tab.
l float. I will keep floats away. L string of string. I will ignore char. What
okay,
else do you
no, no,
have?
no. We have
L
atoms,
string.
chars, floats, integers.
Yeah, I'll ignore floats for now.
Sure,
String.
Wait,
And
chars?
I
Erlang
think
doesn't have chars.
it does.
It doesn't.
it,
No, but it is
I
in
don't think.
here, atomic literals. If L is a character literal, then it is equal to char. It's written here
Well,
in the docs.
unary op. So that'll be a unary operation. So we're gonna do u plus, u minus. Although I'll put them here, but I'm not sure if we want to represent those guys here. But let's just do them. So
Hmm.
u b
Okay.
not just this. Um, why is it like this?
And it's
Type
they don't separate strings from bit strings apparently. Baguette.
okay.
Actually, they must actually because those are different types.
But it's not in the atomic literals. Man, I'm literally looking at it.
B minus, B mult,
They have atoms,
uh,
character, float, integer, and
B
string.
div, B ren. I think we have integer division and our stuff. I'll ignore those for now. But I think we should add here also like B send, which we don't have yet. Um, least stuff. So B least. Let's do least add and B least sub. And let's ignore lists. Let's keep it simple. So, and then we're going to do val string of unary operation,
Oh,
which
apparently it's
will be
because bit strings are
unary
considered
op,
a form of comprehension for some reason.
val
Ah.
string of binary op will be just a binary op to a string.
Oh, I am recording, but I'm not. I
Um,
didn't say what we are doing. We are implementing the beam, in the beam AST in OCaml
we have a
because
signature that already gives us uh, the stuff to convert to a string, essentially.
yeah,
In tag style.
because we will in the next step is to grab whatever the preprocessor spits out and and translate that to this, and then we serialize it, and then we have a neural file. And that's how that
Here
works.
comes the silly part of OCaml. You need to duplicate this.
Yeah, it's not done. This is I don't know how Magetta is doing this by memory. It's kind of impressive, but this is
I read
supposed to
this
be the
during
beam.
my whole afternoon because my workday was extremely boring. So
Oh, okay.
it's going to be a function that just pattern matches the u plus,
Okay, but
and
then
it's this.
it comes what Marino said, right? Bit strings are considered as a comprehension, so we should just have strings on line 24 up.
Yeah, whatever, man. We can. That's a not a minor adjustment. That's fine. I can remove it. You not.
Okay, my first question is this specifying what? Okay, we don't have a behavior in here, so this is we're gonna have to figure that out.
No, not yet. Behavior will be for the big boys. I don't want to worry with that today.
For the big
String of,
boys, that's so cool.
and we're not there yet. We're still walking, learning how to walk here. Binary OP function. I'll copy these because I don't want to keep
Wait a moment. In OCaml,
typing.
if you have types specified in the signature, you have to duplicate them in the structure.
Yes, isn't that amazing,
Uh,
Mm,
Linus?
that's kind of silly, no?
Magenta, why do you need the signature?
Uh, I don't know. It's
No,
just that
he
second
did it
nature.
automatically. Like it's instinctive to him.
It's a
That's why.
way to think, man.
Oh,
So if
maybe
it's
at some day we're gonna. No, yeah, that's never gonna happen. This is specifically for the meme. So, but anyway, that's
so if
okay.
it's minus, if it's a
Oh, we have a
multiply,
party
so
tonight.
this,
Yeah,
we have a party. Are we having fun? I have no idea, but
I
it's a
am having
party.
fun. No, I am having fun.
So RAM, I think it's these, right? RAM.
Yes, it is that.
Let's just do send is the these, right?
Yes.
Okay. We can add the others later. That's fine. Perfect. What's the issue here? String of literal. Oh yes. Let
Wait a moment.
string
Do we need
of.
send in on this type? Like, are we gonna use send for anything?
Oh, it's a binary operation as well, right?
No, okay.
So we're gonna convert
Uh,
it to
Even
send
if
to
we
a
don't
PID.
expose it to Karuta in the beginning, we're going to need it to talk to Domino.
Yeah, that's fine.
Indeed.
That's fine. But you need an expression. I think we're missing an expression type, which is
Wait,
the
this is not there
protagonist.
yet. Man. This is not man. Wait a sec. I am going to do the next. Literally here.
Okay.
Module type. Let's start by that. Expression. It's going to be a signature, and I will ignore that for now. Let's finish this. Oops. So a, right, and then we just wrap it. An integer. It's a string of int, and then it's the e I string. Oh, it's just this. Uh, we probably don't need these, as you said, but we would likely. Actually, I think we need to do these, in fact.
Ah, is that how that works?
That
I
is
didn't.
how it's shown. So,
Okay. No, no, yes. In the literal form, yes. But how does that look on the AST?
so we're gonna do here just escaped s, just to be careful. Um, actually, I think we should do that from here too. Oh no! Wait! This is emitting like to the thing, so you gotta emit with the thing. So it will be these, but with just these, right? So
Don't
uh,
forget.
thank you.
Yeah,
Yeah, and okay, so that's it. Now let's go to the module expression. Now this signature will be a bit hairy, and I need you guys to remind me of things, because I so let's
I
start
think we
with a
should
type
start.
two
I think we should start by the leaves, man.
pattern. Type word. What else we have? A clause. So those are the things I can think of. Then we need a literal,
Pattern.
which is obvious. So type
Yeah, let's start with the
literal.
literal. I think that's the most important one.
So this, let's put also the var, because we have that var. So type dot var
There is a typo.
to
You
AP.
did val.
Did vol indeed. Vol. We can represent tuples, I assume. So, oh man, what is wrong with my typing today? I've been making so many typos. It's let's put them as a list for now, at least, until we think of something better. Um, binary. Oops, bomaru. Can I typing? So it will be for like binary bit
Yeah,
strings and
yeah.
things like that.
The block. Okay, then
Um,
we have blocks
unary
apparently.
blocks.
Yeah, there is something here called a block expression, which starts with a
Oh, that's the
begin and
beginning
starts
thing.
with an
Oh, it's
end.
just a list of t's, right? Block, I think, is just a block is a list. Oops, it's a t list to t. I think that's it.
Yeah.
Um, unary, it will be just the type
Magenta,
dot.
your modules
Yeah.
are a bit funny, right?
My what?
Module type, your modules.
Why?
Module type, but it's not really types, right? Not about type.
of course it's a type.
Really? No, I mean, a module named type. It's not about types.
No, it's not a module named type. It's a module type. You see?
No. On the first line,
That's a signature,
not the
right?
Oh,
one that.
these, you mean?
Yeah.
This is. I was thinking of the. Actually, okay. It's like kind of the node, right? I think that's
Hmm?
the way to go about it. But it's for like primitives in the language. If you think of a
Hmm.
better name, go ahead, please.
That's a valid name, primitives.
Primitives. Okay.
Okay, but
Then so be it.
man, I think we should jump some of those. Like, what the fuck is a compound pattern? You know? Oh, this is
Uh,
destructuring on the equals. I see.
so unary. Let me do the binary operation. Actually, this is calling unary is not all right, right? I'll call actually binary op, so to not mistake with this.
I
Binary
think we should
op.
focus more on functions and literals and function calls.
We're gonna get everything done, man. Don't worry.
No, but I don't think we need
Today.
everything now.
No, we will. So
uh,
that's I think for now
backward,
that's fine. I mean, we
backward.
might want other things, but I
What the
think
fuck is
we
block,
can.
Magetta? Block as in like C?
It's like
No,
begin
it's
end.
begin and end.
Wait, does Erlang have that?
Yeah.
I don't remember
It's a
that shit.
weird language, man. It's a very strange language. So type T, type expression, and then
Oh,
vol
patterns.
literal
Let
again.
me scroll up here. Patterns.
Type literal.
Yeah, literal.
It's primitives now, right?
Yeah.
Primitives literal
Bit
to a
string.
T. Then var type. Ugh, yeah, this will be problematic, Lemus. T vol. We need the wildcard.
That's
Uh,
called. What the fuck is
just
this
this.
called? Universal
Vol.
pattern. That's what they
Ah,
called.
cringe. I'll just call wildcard.
Cringe.
Very
Variable. We
cringe.
also need variable.
Yeah, I do have there. Var.
Oh, we are calling var the variable. Okay.
We probably need cons.
Yes.
If
Both for expressions and for patterns, by the way.
yeah. Vol list. T list to T.
We have any difference
Vol.
between the var and the wildcard?
What?
Uh,
Sorry.
yes. The in
A
the
var has a
AST.
name.
Yes. In the AST, the universal pattern is hard coded to be underscore, and on the variable,
Okay.
it's where is it?
But I mean,
Uh,
regarding the workings of it, besides like binding a thing, that's the same?
Okay. So maybe we want. Oh, let's put record here since we are already here. I think we're ending, right? So primitives. Uh, it's an atom to a primitive atom with a T list to T. So they're named essentially. Uh, I think we want the map also. So a map would be pairs of T's in a list to a T.
yeah.
And I think we can do the pattern match with like variables as well, but forget about those. I don't know how to deal with them. So let me copy these, put this because I don't want to type all of that again. And we're gonna do guard. So guard, which might be, uh, actually a guard is very simple. It is just, remove all of you. So it is just a uh, expression, and then we need an expression to the T,
No, wait.
conj.
Let me
Let's do
scroll up.
conj, and let's do
Guard.
disjunction. So T list. So that is the conjunction of a guard, right? So that is the thingy. Oops.
Conjunction.
And this, yeah, conjunction, disjunction, that, and also in the other trash.
Ah.
So just
Okay,
this.
I trying to find that. Yeah, you
And the
don't
last one,
specifically
I think.
dedicate that there. Yeah, but we don't need to have be exhaustive right now. This is just like.
Yeah, yeah, yeah. It's just a first pass. I got it. So type T, we need a type pattern, type guard, a type expression, and then we're gonna make a make pattern list to a guard list to an expression list. Oops, expression list to a T. Then we're gonna do patterns, which would be a T to a pattern list. At least this is like standard OCaml trash. So
Standard
raw,
OCaml. What is not a standard? Polymorphic variants?
well, that is a bit. That's a bit. Don't talk about that, please. That's obscene. You don't talk about that. Okay,
Okay.
so now let's just start doing things. So the beauty is that later we're gonna need positions, right? So we can pass positions as another module. So imagine that you have like a position module type,
Mm,
okay,
no,
and
no,
then
no,
you
no.
just pass the position
I have a
here.
proposal. Go to the AST module, please. We can do the same trick that we did there in here. Look at line 19.
With location.
Yeah, this is a parametric type that receives something, right? Which is in that case parser clause prime.
But how you're gonna convert that to a string?
Well, it doesn't really matter how we're gonna convert it, but we can embed the location by using the same trick.
Yeah, but my point is you can always do these, right? Position, blah blah, and then you make that garbage expressed inside of one definition of these, and then you just pass it here like so, like uh let me think. So like make let's call it make expression system. That's going to be the name. And
Okay.
then you pass the pause here, you see, with the position. Something like that.
I
But
understand
this
what you're
doesn't
saying,
exist
but I think
anymore.
we should just use the location thing. We don't need to make this a functor, but that's okay.
Oh, whatever. So this would be like you just do like annotation, something like this, and then you can have all the garbage here, but whatever. So module, it will be recursive. I don't even think. Let's start doing this. So again, signature, because I like them.
By the way, I
Uh,
just learned today that there's apparently something called the effing semantics for ML modules.
What a name. F semantics ML
Effing
modules.
semantics because it's defined by elaboration to system F omega, basically.
oh,
Ah, okay, that's cool.
fancy.
That's cool.
Primitives dot literal.
Man, I felt so embarrassed that I didn't notice that behaviors are modules. But okay.
Well, technically, they are. Yeah, they are modules with a particular signature,
Oh, no,
right?
functors I should say to be
Defined by
more
the.
pedantically precise, right?
Are they functors though? They
Yeah,
don't take
because
another module as
no,
an
they don't take
argument.
an argument, but you implement the callbacks like you
Oh,
would
they
as the
technically
argument.
do because you have to provide an interface for them. Oh, no, but then they're just inherited. I
Yeah, so but
don't know.
they fulfill the same purpose. That's what I mean. That you implement an API that is very specifically defined, and you gain stuff for free, which is this. So
Oh, trash. Let me call this T. What do I call T node? E binary of. I'll call it binary element. Okay, it's just my evil thing. For now, it doesn't exist yet. Binary element. We're gonna do e unary op of lowercase primitives unary op with
Oh,
t.
expressions. Let me scroll here.
And then we're gonna do the binary. So I'm gonna just copy this binary. So binary, I think it triplet is fine. Binary OP. Perfecto. Let's do record. E recordo of primitive. Where it's going to, it's an atom, right? Atom with, I think I need this. Primitives again, with the atom with another T, and it will be a list. And we need the access of a record as well on this trash. So record access, recordo access. So this with, have you guys watched this Steins Gate?
Only the first episode.
Help
The
Psy
movie.
Congru.
So you do know the episode where he says nostalgia drive? That's me today. He comes up with a name right for the experiment, and it's like nostalgia drive. That's actually a good name. Okay, so that will be it. We need likely one for record update as well.
Marinho, I'm kind of trying to think what's going to be the best approach to try to like um, refine this first draft that Mageta is writing. I think we should try to settle on an example and see, grab the AST that we're going to pre-process and see, okay, how do I grab this data structure and make it work on Erlang,
We
right?
had the block up there, so I'll do it as well.
So I think we should do
Um,
like that, iterative mode, because I think trying to do, okay, let's speculate all the possible expressions you're gonna need. I think that's not gonna work well.
Well, it will work fantastic.
Speculate.
Just trust, man. Just, just trust. We don't have functions yet. I just noticed that.
Yeah, we don't have functions.
Um,
What do you
okay, so
think,
let me
Marinho?
define the value t.
Uh, I'm actually okay with defining the entire AST up front because it's basically transcribing documentation, right?
Yes, and then we stop looking at it.
Well,
It doesn't
but
sound very good, actually.
we are
Essential.
potentially adding
History.
complexity that we're not gonna use anyway.
What do you mean?
Yeah,
We're
for
gonna use
example,
everything.
I think we're not gonna use the blocks for anything at all, but we will use functions,
How
and functions are
how do
missing.
you know?
You will bite yourself in the future, Lemons. I know. I
How
know.
do I know?
I'll delete the match. I don't
Intuition.
want to find it. Uh, well, let me define these at least
You
and
forgot to send my, yeah.
yeah, binary type. So binary type can be of any kind of trash. So integer. I'll just put like two of them, like integers and what else? Obviously binary,
Yeah, you could,
right?
well, atom, I would say, but okay.
Uh, yeah, okay. I guess that's okay. So just so we have something here. Okay, so let's continue this. I'll just make a make thingy for this, which we're just going to take the T. Actually, no, we don't need this. No, never mind. Just this is fine.
Oh, Marinho, you were
So
not here yesterday, right? So remember what I was talking to you before about using a mutable logger and stuff?
Yeah.
So I did a tiny bit of research, and apparently that's how people try to implement dynamic scoping in OCaml.
Well, obviously they haven't been reading Kislev, otherwise they would have implemented it in terms of algebraic effects. Or the limited continuations, which are the same thing.
Sure, but that means
resting too
that
much.
I had to do the thing that I told you. So we are using a mutable logger.
And that's the wrong abstraction, unfortunately. But oh well.
Well, we know it's wrong because the inner machinery to make it work, although the mass is not exposed to you as a user of the logger, if you read it, you're gonna cringe hard. So
Can't we just parameterize the logger to take different implementations of the logging, the primitive logging functions?
yeah. So here's the thing that I haven't also told you. So Magetta, when he reviewed the thing, he made a couple of requests that uh, implied that I had to transform the logger to a functor, and you pass to the functor a platform that you want to log the stuff in. So like we have two axes now. We have the level of the logging, and we have where you're going to be logging it. So all of these
Okay.
things complicated the thing when it turns out to be very ugly. And I'm not saying it's the final, like the definitive implementation. It works. I tested already, but it's definitely not pretty under the hood. So we probably should improve that at some point. Uh, but just for you to know, because the interface is the same, so you're not gonna notice when using it. But if you open the logger module, you're gonna see some hairy stuff there.
Some beauty, like a PA program. Eh, I'll
Oh,
just use this.
and you may ask why Magetta wanted to be able to change the platform. Because he wants to be able to have to
LLSP.
log LSP, yeah, to use the logger to send the stuff instead of reporting to the terminal, reporting to a socket. So then we made a functor that allows you to parameterize that.
Come on, man. It's 2025. If you don't have a LSP, you're a
No,
joke.
I think like that's okay. Like I think that's a totally fair wish. That's why I did it. But I'm just justifying why it became so much more complicated than what Marinho saw last time.
Why is it fading? Binary element, unbound constructor type element. Oh, this is not recursive.
Well, I was feeling guilty when we did the solution using
Eh,
object magic. I
but the
was
type
feeling
is recursive with it. So, what the heck?
syntax error after unclosed signature. There is an
This
end
Oh, it's
Don't
piece
you
because
need
somewhere.
rec?
it
you
is
have a
correct. Is
hanging
it because of
off
this?
in there. Yeah.
Hanging
Maybe.
off. Oh, in this line. You need to finish this line, maybe.
Yeah, maybe I think that's it. T with this, right? Yeah. Okay. So that is the issue. So
You
record,
don't need rec on the definition of these types.
Your autocomplete screwed you over, Mageta.
he did. He keeps doing that. That's the thing I don't like, Marinho. That's why I want a good one. Actually, it's not pattern here, right? I'm stupid. It's a p record. Uh, p map because we did define it in there. So the maps are just t. Oops.
Magenta, you don't
T.
really need to prefix all the stuff if you're inside the module, right?
Sorry, Nata. What?
Oh, he's
You
talking
don't
about the
really need to
prefix of the P.
prefix all the constructors if you're inside the module, right?
No, not really. No, I am just doing because I think before actually providing an
It's
implementation
it's
if I need to.
yeah, it's habit.
It's
We're all
it's
used to
habit,
doing
yes.
this.
Struct, if I can type correctly. Like the downside is that I'm doing in line and that I'm having to copy this trash all the time. But
Yeah, and I
I don't
think
think
that
there is
having
any
the
other
signature
function
is
we
a
want
little
here.
bit debatable because we're not gonna allow like
Yeah, export this. I get it. I just don't think I just when I started this, I don't know if I needed any functions. You see, I don't think we do. But we can pull this out later. That's fine. So let's just do now another struct. Let's call it. Actually, I'll do the same pattern. So I'll copy this trash. 16 up. I'll copy this.
because like if we had
I need to add. Let me use my mouse. I don't like using my mouse. Where's my mouse? Oh, here.
okay, actually there
Here.
is a reason that somebody that we can justify this like maybe there will be someone in in a very
Crazy.
depressive and miserable state that will look at this and say, you know what? I want to compile this to the JVM. Then,
That's I'm sorry for that person.
then these make sense.
Then this makes total sense actually. I mean, it's usable on other things, so I'll
Well,
be
but
happy for
yeah,
that, I suppose.
you you can like it's the same thing that Marinho was talking about. Oh, are we gonna make Domino unused if you're not using Karuta? The answer is theoretically no, but practically probably. Like, are you gonna be able to use Domino with your closure? I don't think so.
Why
I
not,
doubt it a little
Samus?
bit.
Why not?
No, it's not about the theory. Like, it makes sense to that it can be combined. It's just that I don't know. I have a feeling that we are making some decisions that work best if you have a unified thing, everything in the beam. And there's
Maybe.
probably some assumptions that we are using that assume that.
Indeed, maybe as well. We need to actually store patterns. So pattern, now it's the beauty because I just do this.
Are they of software?
Patterns of software.
Yeah, but that's a great book. We read that.
Expression and guard. There we go. There we go. Somebody very miserable will export this to the JVM. Thank you, Lemus. In here, we actually do want other things because I want an easy way to make this garbage. So let's do that. So pattern T list aguard T list. I don't want to keep defining passkey module records everywhere. So list, and this will give me that garbage. Uh, Patterns. You just pass the T, and that will
Man,
give
it's
me. So it's
very
an acceptor.
silly that you have to repeat the type. It's very silly. Like, there must be a
Well,
PPX for that.
and the guards and the body. Body. Expression T, and this is guard. So who is messaging me, by the way?
I'm
I'm
not.
not
Uh,
seeing the chat. So
I'm
what
not
is
the
the
one.
part, Lemos, that is silly about writing the types?
The part that you are repeating yourself, like inside a signature, you're defining a type T, and you're not making it opaque. You are actually saying this is a record. It has three fields inside, and that's okay. But in the
Oh,
struct
but you
implementation, you
cannot
cannot
write it
just.
at all, right?
What do you mean?
You can just not write it at all. Like, you don't need signatures,
yes, that's an
usually.
option.
No, 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 no.
Just don't.
That's okay. But what I'm complaining is, if you were specifying a signature, you're already defining the type. When a struct is being defined with that signature of the module, the type should already be available for you. You don't have to redefine it yourself. If the only
Um,
exception being if the type is
You have no
opaque.
way to know if you want to expose in the same way. It can be potentially different.
Oh yes, I understand that
as
it can be different.
that doesn't
Then you
work,
have to
Lemos,
specify
because you
it.
can use multiple signatures for the same struct.
But isn't that the case only if the type is being inferred? If I type it myself in a annotation, why that shouldn't work?
Because
Wait,
you're assuming that a signature will only ever be used. Well, you're assuming that this particular struct definition will be used of a particular signature, which, first of all, is not syntactically evident from the point of view of the struct expression. But more importantly, you can then seal the struct with a different signature, and then which signature should the T come from?
Wait, repeat that last part?
You can seal the structure with another signature that also defines a T.
Oh, you mean if you're
Which
using
signature?
two? No, wait. If you're swapping the signature, it's gonna be coming from that new signature that you're swapping for it, right?
No, 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 no. You're not swapping. You're using both in different
Oh, yeah.
places.
Okay, so that's the question. Yeah, I see the problem. I see the problem. But I'm just complaining about default behavior. Like in all of these corner cases that you're explaining, I think that's okay. But I don't know. I think it's just silly that you have to copy the type exactly the same.
No, you don't, right?
Yeah, you don't.
No, you cannot copy exactly the same. But in the case that you are, they don't even have like I'm talking about some sort of syntactical sugar. So you know this
Oh,
in
okay, I
Zig,
see.
this
No, I
doesn't
don't.
have. Yeah, okay, but this is just a syntax sugar for something else, and it's just
Actually,
for
it isn't.
convenience. No, it is. At least we use
No, it
that
is.
as a syntax
No, no,
sugar in Lyceum.
it's not a syntax sugar. It's actually a compiler primitive.
No, yes, but
It
uh,
means Lemus means has a
yeah,
shorthand.
Marinho is being
Imagine not
pedantically
repeating
for no
myself.
gain. Yeah.
No, you used a pretty bad expression for that, Lemus, but
No, no,
yeah.
no. When I say syntax sugar, I mean that it doesn't have the same, for example, these in C++, for example, or modern OOP. It is not the same thing. It's just a
You mean
handy
some
trick that they
easy
did
way,
there to
right?
help you to get more convenient stuff.
Um,
So, Lemus, you
ac-
might want something like type public da da da, and then you don't have to write the definition, right?
I don't know if you're specifying the
Say that
with
again,
only
Nathan,
one
please.
signature, you could do I don't know this or something.
Not a request. Say tarara again, please.
Da da da.
That's funny. I don't know why.
Go,
What
Marinho.
the fuck is this?
well, first of all, the reason that there is this thingy in Zig is that structs are actually first class values because
Uh huh.
types are values in
Uh
Zig,
huh. Uh huh.
which means they can be anonymous, right?
Yes.
Which
Yes.
means if the struct is recursive, in the sense that some member of the struct uses the struct as part of its own type signature, you
Yes.
cannot get the signature any other way other than using at this.
No, no. That's why I said immediately after that in Lyceum we use it as a syntax sugar. I'm not saying that the only purpose of this primitive built-in is to just be sugar, but we use it as sugar in the game. Remember?
The second problem is that if you use the this thingy that you suggested in OCaml, um, that's going to be another keyword, which well, that means you cannot have a variable named this, right? So there's a trade-off there as well.
Oh, of course, of course, of course. I agree completely. There is a trade-off. But I don't know. I like these sort of things that okay, 99% of people is I don't know the statistics, but let's say that 99% of ML people make module structs with only one signature. That's the majority of the use cases. I think if that's real, that statistic, I think we should have conveniences for it. That's kind of what I'm proposing here.
I don't like this OCaml version C inline. This is as I don't know if you should even have this. But I'm just on copy mode here. So this would be atom with an int to follow that. C option of primitives atom. Ay, ay, ay. So let's copy functions now, Lemos.
Functions.
Function.
Let me look at
So
it.
functions are just
Okay, there are
name,
two types of.
arity, and
There are a
clauses.
couple of actually types of expression
So
functions.
name, it's just an primitives atom. Arity of it,
Actually, there are multiple. One, two, three, four. Okay, there are four
clauses.
types of function expressions
It's
and
still
two
that.
types of
You
Just
have
function
do
arity
calls.
arity.
on the function declaration?
Yes, not
Wait,
declaration. Not I don't think it's declaration that
only when
like
using, right? Or
yeah
capturing
I
or
think if
something.
declaration is a little bit misleading in that type. But this is a draft anyway. We're gonna change a lot of things.
Why would you like to change a lot of things? Tell
Oh,
me.
because like Nathan said, when you're doing a function declaration, you don't need to specify the arity, only when you're using it in such like a high order function.
Also, you could improve the
So
marketing, I get. If you're generating some of this code, you can say AI powered on the README.
Only when you're
That will
using it.
attract
What do
more
you mean,
people.
Lemos?
If you're using a high order function such as lists map, and you want to use something that is not a lambda, you want to use like another function, you're gonna do this thingy that like keyword fun and then space, then module of the where the function lives, column, the function name, slash arity, right?
Yes, but that's not a declaration, that's a reference.
That's so you agree with us. It's not a declaration.
The declaration does need the arity though.
Isn't like implicit by the number of arguments that you are listing?
Well, it needs to become explicit at some point.
Oh, but it
I
needs to
guess
be
they chose
explicit at
here.
this point.
But at the AST, that's just bad modeling on the type because it can be mismatch, right?
It can mismatch. What do you mean?
As in, if I have like a list of the name of arguments, it might not match necessarily the arity at the like type level, right?
Yeah, you run the risk of having a mismatch on how many arguments you
As
have in the
in,
number.
have multiple flags of bulls instead of like
Well, I guess
modeling
here
as.
they are assuming that it will match and they do a check at some point. Kind of like, we actually don't do that check ourselves.
What I
We
mean,
should.
instead of
Yeah,
checking,
we
why
don't
not
do
just
that check ourselves,
deriving it
right?
when you need the arity, right?
give me
Ask
just
the
a
question
moment.
again.
Instead of checking eventually, why don't you eventually derive from one source only, right?
But we do. We do this in the parser. So when we are
No, no,
parsing,
no, no. I mean regarding the arity on the AST.
uh, well, but probably they have.
Well,
Um,
Erlang is doing the same thing that we are, basically.
yeah, yeah, yeah. But I have a question. I'm looking at the documentation. Where is the function declaration? Like, where do we put the body of the thing?
I think the body is inside of the clauses, no?
No, in Mageta's uh, modeling, yes, but the source of truth is the doc, right?
Yes.
Oh, it's this one. I see. I think. Yeah, okay, it is clauses. He's right. This actually is in the docs. Yeah, he was not joking when he said I read all of it. By the way, Mageta, if you have to go have dinner, just do a committee and you can go. If you have to go.
No, no, not yet. It was just noisy here. But I will
Oh,
in a
Marinho.
bit.
Yes, Nathan?
So that's because they have multiple clauses, right? Then how do
Yes,
you know
yes.
which one is supposed to be like the first one,
No,
right?
it's but well, the order
Same.
does
I mean, on the
matter, but
parsing,
they
they
but
have
they're
to
matching
decide.
orders.
What I mean is, if you're writing multiple clauses on a function, how do you know which one has the the arity for real, right?
They must have the same arity. All the clauses must have the same arity.
Yeah.
Okay, but if they don't, which one do I assume is the correct one? As in the
Well, we
first,
would have
right?
to fail the compilation at this point because there's a problem in the parser.
Not in the parser, no.
Well,
That
yes,
would
in the
be a
parser
very
because this is
context-aware
actually
parser.
well, this is actually part of the hmm.
Uh,
Actually, yes, there
If
would need
they
to be a
are,
check at this point, right?
I mean, if they are doing this on the parser, then that's a very context-aware parser. Like, too much for my taste, for sure.
But you're talking to Marinho, man.
No, no, there is also you, man. I remember doing a lang with you, and you wanted to do, like, everything we could on the parser.
No, no, no. You don't understand. You don't understand. Marinho is in a completely different level of
Oh, he wants,
context-aware
like,
parsers.
evaluation on the parser, right? Like,
Yeah, he
it's
wants to
only one
unify
step,
everything
the
in the
whole,
single thing.
the whole interpreter.
Mm.
Wait, but on Erlang specifically, when you are doing the declaration, and I want to declare, I don't know, the same function but with two different arities, is that like one definition only? Or that's multiple definitions indeed?
That's multiple
In
definitions.
Erlang or in our thing?
Lang,
I have no idea. Marinho?
multiple
That's multiple
definitions, right, Marinho?
definitions because like the way the syntax works, if you have a function with multiple clauses, you separate the clauses by using a semicolon, right?
Yeah.
And then you finish the definition using a dot.
Marinho,
And there are
in
dots
Elixir?
between the definitions if they have different arities, you see?
Yeah.
Hmm, I see. So you list the clause and then you end the whole declaration with dot. But man, isn't in Elixir, like doesn't in Elixir they declare each clause like completely separate? Like they do a def something, declare a thing, and then they just do again if it's the same entity with a different match
That's
on the.
just surface syntax, right? Haskell actually does the same thing. If you define the same function multiple times, that actually desugars to a single function with a pattern match.
Okay, so they just collapse in a thing, right? When
Yeah.
doing the beam.
Yeah.
Interesting.
I'm I'm pretty impressed of how much Magetta already had prepared in his head for this.
I cannot even comprehend how someone can like this just in memory.
Yeah, no, that's maybe he has
It's
a
a
second
bunch of
monitor and he's
trade.
looking at it, but come on, look at this, man.
I printed some pages and I have on my desk.
In paper?
Yeah, in paper.
Wait, you
What's
have
your
a
upset
no no
with
no 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 no
paper,
no.
Magetta?
Wait, you printed the Erlang documentation in paper and you have in your desk.
Some of them, not all.
I only believe by looking at it. Please, photos, evidence. I need the evidence.
Yes. Oh, but
Are you
it's just
surprised, Lemos, after he showed us
I
the documents on
I literally
Sunday?
brought like yes,
No, no,
40
no, but
pages of
no,
diagrams.
but that makes sense because it's lighter than a laptop, and it's easier to share with other people. Of course, he would print that, but he's alone in his house. You see?
Don't
But
you like
don't you guys
go
have like
away from your
smartphones and shit?
computer and like paper, like to touch paper?
No, I touch paper because I buy books, but when I have to like design some stuff, I don't remember the last time I printed something like that in paper. What
You're
did you ask, Nathan?
you're strange,
Don't you
Lemus.
guys have like smartphones?
No.
I mean,
So
if it's regarding
Counter
carry around weight, you have a smartphone already, right?
counter arguments, Nathan. Smartphones are small.
Oh, okay.
And they also suffer
Okay,
from the
that's
same
fair
problem
enough.
as the laptop. It's harder to share. We were four people. You can pass the paper around. It's lighter to carry
But
around. I'm very
no, no,
pro paper
no.
in that
That's
sense.
only regarding the size, as Marinho said. The weight and other stuff, it's not valid, man. You are carrying that either way.
No, no, it's valid because he didn't have to bring a laptop, which has a bigger screen.
No, I mean the smartphone.
wait, what?
You would use the paper instead of the smartphone because of the size, right? But weight and other stuff,
Oh, I
I
actually
don't see the
just didn't
point.
want to bring my laptop in São Paulo, which is another reason.
No, no, no. Okay,
Yeah,
that's also true. But even if you lived there, I think the paper would be smarter, precisely because it allows you to like easier sharing. It's lighter. Uh, uh,
Yes.
so they're like Nathan is just crazy. They're ignoring these advantages.
no. I'm not talking about laptops at all. I'm just saying, like, you would not need a laptop anyway. You can just bring a smartphone, right? So why
But
even
it's
bother
small
with
as
that or
fuck,
the
man. What are
paper?
you talking about?
No. Then
But
that's what Marinho said, right?
No, but what I'm saying is that you could solve the size problem with a laptop,
Yeah.
but the laptop has worse trade-offs. So the paper is the winner in all
Oh
regards.
yeah, I agree. I was comparing paper and smartphone.
But I'm pretty surprised that Magetta does the same alone in his house. Like, okay.
Feel old now, thank you.
A new quirk that I learned about Magetta today.
So I don't like this, but I'll do this. Wait, what? Yeah, no, not this. Yeah, there we go. So pattern sys. Okay, now it works.
Lemus, can you generate
Yes.
some image for me on ChatGPT?
Some
Not
what?
right now.
Oh, you're
Some
eating
what?
probably, right?
No.
So
I don't have
some
the
image.
credentials right now to do that.
Okay, so just note in your head, and you can do that later.
Yeah.
The prompts like uh, Magetta writing with Quill and ink, Erlang documentation on a 4 or 5 angle like parchment, right? Uh, yeah,
The heck, nothing.
it's like those monks, right? Like copying the Bible or some other
Scribe.
books or scrolls.
Clauses, if I'm not mistaken. Did you know that Plato was in pro of like was against writing?
I didn't. I didn't know that.
It's like
He was in
pro
favor of
oral
like people
tradition only,
memorizing.
right?
People memorizing.
Yeah, you should just memorize everything. And what is the signature mismatch? Wait, values does not match on the function form, and that is a string to int to a clause list to a t. And the
F
t here
function.
is correcto to me. So did I mistype this? Function f
Function declaration.
function.
Oh, you're missing. No. Actually, it's correct. Oh, it
Name
was
area.
ULSP fucked up though. I think.
Probably. LSP, no camel. No, it is not. It's still. And wait, to t is not included in function form. What the heck is he talking
There's
about?
Marinho,
something that is a
Did I
tuple.
mistype here?
Yeah, there is something that is a
Oh,
tuple, man.
uh, wait, is that correct? That should be a. Oh, no, that is right. So it is these that is a tuple, but this should not be a tuple. That is why. It should be just atom. So it's an atom to an integer. I'm stupid. These, right? Now it's fine. So, okay, it's just 3 arguments for the function.
Marinho, if you had the diagnostics tool that it's pretty much wrong, like I don't know, 30% of the time, would you still use that like every time?
No.
No.
Right. So why do Magita and Lemus insist on using those faulty faulty LSPs, man? Like
No.
they are just
Oh, get me out of that group. The one obsessed with LSP is Magneto.
It should work, man. What the heck? And is that too much to ask
doesn't.
for? You guys
That,
mock me for that, but man,
no,
what the
no,
heck?
no, no, no.
It's like, man, I'm not crazy, right?
Enough now.
It's
Well, I wouldn't
every
say it's
language
thirty
has it, man.
percent. I wouldn't
Man,
say it's
I
thirty
remember like
percent.
going on a meeting with Nathan, and then like he shared his memory tab, like Nathan was crashing, and then like he checked his memory, and then the F sharp LSP was taking 10 gigabytes of RAM. Like that to me is
Okay.
completely unacceptable.
But my point is, Magita, on the case of the OCaml LSP that uses, right? Uh, we agree with you that it should work, like it should. But given that it doesn't, why
Given
do
that
you
it doesn't,
continue
why
to
try,
use that,
right?
right?
That you
I
know
mean,
what? That is actually valid. That's actually
I would be
valid.
just compiling manually like every time, man. I would not press the LSP.
Oh no, we already, but we're getting good at this. At some point, we all say, okay, LSP is going crazy. Let's go to the compiler. Fuck it.
You have a bullshit detector for LSPs, right?
Yeah,
So
especially
I think
the
the
OCaml
last
one.
man, I think I'm almost done here. So the last is the form. with a type
Well, we're
t.
gonna have to go do another pass. I will do that
Oh.
with Marinho when you go to
Do
have
you know
dinner.
about this, by the way?
Hmm? What?
This
Like
is
Lemus.
Can you
including
repeat
the
what you said?
everything from the expression thing.
Mm-hmm.
I just don't know what the with type does.
It's
I think
assigning
we
to
talked
be
about this
the
yesterday, Lemos.
implementation of this
We
type should
mentioned
be
this
these.
yesterday. Wait,
Hmm.
repeat, Magetta?
It's assigning the implementation of the type inside of this trash should be these, right?
Ah, okay.
You see? So that's very convenient.
That is.
T form, and it's just this. Okie dokie. Now we need to do a structure. Actually, do we? Do we? No, no, no. We don't.
You don't
We
need
will
to
not do
actually
that.
implement stuff, Magetta. You can just describe
Yeah,
your
you
type.
can't just type modules all day, right? That's
You don't
let
need-
me call a thing here
let
called
me-
builders. Okay, builder, and this builder will be Bob.
That's
No,
our
I'm joking.
enterprise of human.
Which we're gonna take the sys, which will be our make expression system, which we can flip to any garbage we want. And then we're gonna open sys inside. And here, my friends, it's going to be beautiful because we're gonna do lit, and then we're gonna do expression make. Why is it not open here? Sys.
What the fuck's that syntax, Magetta? That lit L.
What do you mean, man? It's
It's a function.
literal. It's a function.
Well,
Why?
that one
Oh,
is
Why is
easy.
it even
yeah,
bound?
yeah. I think that's been like ages since I looked into
All right, I didn't
YAML
define the
code.
makes. Kill me. I didn't define the makes, right? So it is just what's the name of this trash? Need to jump back to the expression. Express. SPR. Uh, I defined just literal, so it is just that, I suppose.
Yeah. No, but you can add
What?
to reduce this, right?
Yes, but eh, why is it not? Oh, I'm stupid. Let's just do this. Gonna need this for a lot of things. So the next is the var, vare. It's in Latin. The atom, int, a tuple, I guess. Type,
Type.
not tuple. Cons. Oh, if we have cons, we need new as well,
Yeah. No,
which
no,
we
no,
did
but
not define.
no. That's the thing. When you go to dinner, we're gonna go do another like cover over the everything that you typed, and we're gonna fulfill the holes, including new.
Well, new can be a literal. So you just need actually the type. Oh. The primitives, rather. So we can do this. That should be cheap. New
Everything broke.
L.
Congrats.
I need to relaunch this trash. Man, it's a
Congrats.
miserable experience, is it not? It's truly. Okay, so that mhm. So cons will take a head and a tail. I'm doing the thing that I don't like on Haskell, but I give up. Ecoms, which is just a tuple, right, of those two.
Wait, which thing you're doing that you don't like in Haskell?
Like the just using a letter like as a variable,
Ah,
and then you
that's
and
very
then
bad.
out of like the 10th function, you don't know what like x means. Like what
Yeah,
the
no,
heck?
no, it's very fucked up. Yeah.
So tuple will be the things inside of it, named like t's. Does that help, Lemus? Uh,
Does that help?
Meet tuple t's. Okay. An integer will be just a literal. So integer. It's not inside of here. Primitives. What is broken here? Like L integer. That is correct. Oh, Need to modify, of course, in two places.
Ah,
Why we
see?
shouldn't you?
This is what I'm talking
Why
about.
shouldn't you? Why should you not, right? Why should you
This is
not?
what I'm talking about.
Var and atom A. So an atom is also just a literal, right? So atom, do we have that?
I don't remember.
I hope so. A. And the var needs to be an expression, right? So it is E var V. Okay,
Okay, but
so
is
we need
this?
also
Yeah, what are we gonna use the AST signature for?
uh okay, so the plan here is so this builder is trash is for creating the AST node. So the AST is just accumulating all the forms together. So the signature for the AST, I was planning to actually use it on the emission of those things. We can probably omit this for now. Let's
Sure.
ignore this.
Does it
I
compile?
was just thinking of a way to put all of them together. Yes, they should compile. We still have a shit ton of stuff to do, like lists. Let's do lists because we already have stuff. So list expression, and now I'm gonna do a function that will pattern match. If it's new, then new. Let's make it recursive. If you have x and xs, let's do cons with the x and the list and call it recursively. No, Marin will bite me, will it not?
Actually, I
Obviously.
won't because this
He's
is efficient.
watching. He's watching.
Yeah, Dad
Okay.
is watching.
Okay. So can improve this. Okay. We need to do like function calls, a bunch of trash. I'll just do like patterns because they are dummy. So pattern var ved is a pattern, and then my friends, it's going to be a p var with v, and I'm just going to copy this because I'm gonna do this all the time. So pattern. What's next? Wildcard.
Yeah, let me check the docs. Uh, well, there are more literals than
Uh,
just var, by the way.
well,
Should wildcard take an argument?
No.
no, it doesn't. Thank you.
But
If it's a literal, then it will just then it will.
Wait, is that just so you don't have to type the constructor?
Uh, basically, yes.
That's fair enough, you know, Cameron.
If you're gonna do
Uh,
that,
sorry, Marin.
like if you're gonna do that, why don't we use the Kisly of tagless final style?
Oh yeah, we
The
haven't even
what?
tried to do that. But it doesn't matter, Marin. This is just the foundation. We're gonna improve upon it. That's completely fine.
really. What if we don't, Nemus? What would you do?
Oh,
So
I
this
will.
needs to be a literal, right? Like integer. So it's not a pattern. It's the primitives, right? There's nothing to pattern with. So
No,
integer.
no, no. There is something to pattern. Because
Oh,
an integer
you're
is a pattern.
constructing a member, right? It's not a pattern. You're constructing a
No, no, no.
member.
It is a pattern because you can pattern match on literals. Just fine.
Yes, which is this.
Oh, yes, I agree with you that in this implementation that you are proposing, it is that. But just to like be specific,
The
in
same
the
for Atom.
documentation, literals are classified as a
No,
pattern.
man, they are. They're just encapsulated, right? That's my point. It's just building the AST, essentially.
Hmm.
Uh, which is not pattern. Primitives. And the last is the tuple, which I think we do pattern. So, okay. There's also the cons. Let's do cons. I pattern cons, which is head and tail with a pattern, which I hope we did find up there. We did. which would be just head tail. And last new, because pattern new, which will be just a, well, we can use the pattern literal with the primitives new, L new.
Hmm.
There we go. And then we need a also a pattern on a list. Pattern list function. I'm always scared of doing recursive functions with Marinho around.
Why?
I don't know, man. You're scary. You
Just
are.
don't do a concat. You're gonna be okay.
Yes, that's a good heuristics actually. So
Maybe you will only
pattern.
be like silently judged, right?
No, he doesn't do that, man.
Yeah.
He will start. Man, last that was for time. My one of my first impressions of Marinho. We were on a stream, and then he started talking 15 minutes about booleans. So was that one of my first impressions? I don't remember actually. I think I already knew you for a while. We need also clauses. So clause with patterns, words, body will be just clause. And here's the beauty of doing this. You see that? You see that?
I see.
We're going to do a. Okay, so we might use this. So let's do this. A simple clause will be just patterns. Okay, body, and then we're gonna do a clause patterns empty trash body beauty. And I think that's it. Now we just need to add like function calls, match expressions,
Yeah,
records,
we
all the
we need to
trash.
be exhaustive about it. And I also want to ask Marinho, what is the tagless strategy? Like, how can we morph this draft to use the tagless final thing? Because if it's proposed by the guy that he said, it's probably a very good idea.
And can you show code examples?
That second link I shared, it's about explain to me like I'm 5 years old, basically. But actually, the Kiselyov link has a correspondence between the traditional AST style and the tagless final.
So I was thinking of doing this. So string, I'll
Wait,
just do this and then fill the rest. Um, then we do like a module type.
wait, but
I'll
what are
do a
you?
signature again.
What do we need the Erlang term for?
Wait, you see. Wait and see, little one. So let's do expression. I'm gonna open all the trash here. So type pattern. This code is gonna be beautiful. Let me see. We'll
Yeah,
see.
but I still don't understand
Life is
why
too
we need this
short.
one. But okay,
No, wait. I didn't finish.
sure.
So we're gonna define two abstracts. So this is going to be our abstract syntax trash, where
You're
we're
missing
going
a
to take
letter
this
there, by the way,
to
Yeah, in
on
guard
an
with
guard.
with a
Erlang
D.
term. Same. Where am I missing a letter?
Guard.
Guard. Thank you. Guar. Maybe I'm just
Yeah, but
from the
why do we
countryside.
need this?
Because then you just know how to print this. Done.
Wait, you know how to print this. You're
Like
calling
you
abstract the serializer?
no, wait. So you basically need a way to format the serialization of Erlang terms, right? And I'm talking about the tuple based trash, right?
Yeah, yeah.
So those things are very simple, like terms in Erlang. They're like atoms, integers, floats,
Yeah, but we
strings,
don't have a
tuples.
term. We're gonna have an expression, which is the one from the others file.
Well, you do have terms by themselves.
Why?
What do you mean why? You do have a term.
Man, I'm very confused. Let me explain how I understand it. We have a bunch of things that we
You're thinking of
parsed.
just bundling everything on an expression and the expression being the entry point,
I'm thinking about bundling everything in an expression and then we just serialize the expression.
which is everything a pattern, expression, a guard. Are those things also just terms?
Yeah, that's
So
what they
where
are.
are we? Let me just name this and then we discuss. So these pattern, guard, clause,
Everything
clause.
is a tuple, essentially. After you do everything becomes
Yes.
a tuple.
Uh,
At least according to these docs here.
is an atom a tuple?
Yeah.
No. No.
Yes, it
An
is. It
atom
is
is
this
just an
tuple.
atom.
No, an atom is becomes this tuple.
A,
I'm I'm typing the
a
chat.
tuple has atoms. So how can it be? No, no, wait. There are two kinds of atoms. There's the atom in an expression and the atom. That ano is the annotation, I suppose, right?
Yes, the ano is the where we're gonna be using the location for.
Uh,
It's not the current year.
No.
I
No.
well,
Yeah,
I was thinking of just doing a string matching checker DMs.
the
Is it
word
worth it though, man? Nata? Is
the
it
word
worth it though?
ano is in this section
There is
represents
no
the
way to
location.
know.
It is
You
actually.
have
Thank
to
you.
risk it.
There's no
It
way
is
to
actually.
know.
There's no way to know but open it. Okay, so
It's
I'll stop here and then you do whatever you want.
Sure. Just yeah, make a branch.
Uh,
Thank you.
let me erase this trash.
Don't
Bean.
erase the wrong file, please.
That'll be funny.
That would be
Beans like
tragic.
I type for 2 hours like Golang and then I erase it. Um, bean.
Mario, can you pick this up?
Uh,
I can, but I won't be able to stay any longer than 10 o'clock. Let me just open this up.
Oh.
What's the branch name? Erlang AST
I will be right
repo.
back.
Git switch Erlang
Oh,
AST.
unpaused.
All right,
Cool.
let me
Okay, so my
share
first
the
question is,
screen.
I think it might be better if we have a time constraint like that to just try to make it tagless final instead of just making it exhaustive.
That's okay. Let me just
Yeah, the first thing that we should do is rename
beam.
the files because he didn't put the beam with capital B. So,
Wow. Okay. Unused openlib.beam.
yeah, that's
Where?
the file that he was writing at being abstract. Okay,
This one, right?
yeah, but rename the file please because it's kind of like against the convention.
Okay. In that case, move to bean, not bean. Move to lib bean.ml in
Yeah.
uppercase.
Wait, that's not a thing OCaml people do, right?
What?
Uppercase on the file.
No, we are doing this since the older version. That's why I'm proposing to change it. We can change all of them later. That's not a problem.
This is not gonna move the file in Git, is it?
No, of course not.
Lib bean.ml. Okay, so yeah, this can actually go away, and then I have to move it from here. Git move lib bean lib bean, but this is uppercase.
Okay, so now going back to the nitty gritty of the thing. Um, how can we change this? What Magita just typed for us for the past 1 hour and a half. How can we change it to be the tagless final version?
Okay, so you know all of these enum
Yeah.
tags, union tags.
Yeah.
Basically, in tagless final style, they don't exist. And what do I mean by that? Instead of having like a concrete uh, tree as a data type, what you do instead is you say module um, primitives tagless.
Mhm.
You would do something like there would be a type, and there would be a representation of an a, which is a type variable.
Yeah.
And then instead of saying latom, linteger, string, blah blah blah, we would do something like um, uh, how do I do this? Val atom. It would be it would have the type, which is uh,
A string.
a string to hmm,
Oh.
it is a string. Uh,
What do? Okay. So what do we do with the string?
Basically, every time where you would have
A type. You
a,
make a
cons-
function.
a yeah, every time where you have a tag construction like this, you make a function instead. Okay.
Okay. And what is the benefit of doing that way?
Uh, the benefit is you can actually reuse the host language's type system instead of having to re-implement your own. That's one benefit.
But what if the type
Um,
system of the host is not close to the type system that you're implementing?
Marinho, is there another name for this? Because I think I remember something like this with a different name. As in
you,
using the host language to represent the type system or even the computation, right? Instead of having the eval, just evaluating a function in the host language, we do the evaluation.
well, yeah. The other, oh, as far as having a different name, I'm not sure. There might be. Um, that's something to look into actually. There is another benefit though, which is actually it's easier to extend this incrementally like this. There's actually an example. There's actually an example here, is there? No, there isn't.
Yeah,
There
but
is one
we have a problem
example,
though, because the type system that we're modeling is very different than the OCaml's type system.
which is totally fine actually.
Oh, but you said that you're gonna convert every can tag in there to a function. How would you do that for the new, for example? Would you just use unit for it?
Uh,
I mean, you can just create types arbitrarily, right? As in type
it will be an
something.
int, then like for new, for instance, right?
Yeah.
New would take unit and become a representation of units.
Okay. Okay, but okay, that's about the types, right? So we converted atoms and vars and literals. Okay, but actually, there's another question. What if I want to group them?
What do you mean?
The literal type is grouping a bunch of stuff, right?
Yeah,
So we don't, in the tagless final way, we don't group them because they are functions. Or you're gonna
we
do
don't
what
group
Nathan
them.
said and use in GADT.
We don't group them actually.
Okay, that's bad because I think you lose the grouping semantics. But okay.
I mean, we
Uh,
could, but there's no reason to do it necessarily unless you have
Oh, I guess you
a
can
reason
put
that's
you
unrelated to the.
you can put all of those related functions in another module called literal, right?
You could, yes, you could make like how do I do? Hmm. Yeah, you would have to
Marinho,
do something like go on, Nathan.
the thing that came to mind, and I don't know the relation with the tagless final, but it seems it was HOAS, as in high order abstract syntax.
Hmm.
Mm. Yeah.
Yeah, I'm not sure if it is related or not. It might be.
It sounds like
It
it
might
is
be.
by the name. Okay, continue. Okay, so we converted our types to functions. Then what do we do?
Then in order to use those things, you would do something. You would actually do you write a functor. Uh, you would make a functor uh, like eval taking m, which would be a
Primitive
primitive
tagless.
tagless.
Yes.
Um, and then you would do something like struct
Yeah.
and, right?
Yeah.
Then you would probably do something like openm, and then you would do something like, I don't know, let, just giving an example, let's say there's no cons here, is there?
Yeah, we can make a cons.
Cons would take an A representation
Oh.
and another, oops, A representation
And return an A representation.
and return.
It's a
Hmm.
little tiny bit weird, but okay.
Well, technically, we would have to do something like this if we want to be like A, B, and those need to be quoted.
Okay. Because the types are very different, right? The head and the other one is the not already a list. Okay. Then what's next?
I mean, the being does allow you to put anything you want in the
Yeah, no, but
second
we have to
slot in the
conform
const.
to OCaml.
Uh, okay, then you would do like here's an example program. Let's just say it's just a list 1, 2, 3, okay?
Sure.
Then you would do cons int one cons. Let's use the thing that OCamlers don't like, shall we?
Yeah. Nice.
Int two cons int three new.
Okay, I see what you're doing, but I'm still asking myself why would you do this instead of the tag version, the tagged version? Because you said one benefit, you can use the host's type system for your type system. Fine, but I think because you're implementing Erlang's things, we're gonna have to create types anyway, like Nathan said.
I don't think I said something like that.
You did. It's being recorded. You did. You can just create the types. You said it yourself.
No, 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 no. I mean, as in, you don't have a new in your language. You can create like type new on OCaml, right?
Exactly.
Not
So
as
you
in
said
other
it.
things.
I'm just saying
No,
what you
no,
said.
yeah, but that's on this approach. You can do that if you need to represent that type, right?
No, completely. I'm fine with that. I'm just trying to understand that. I understand. I think I understand what's going on, but I don't see why yet you would do this version of the tagless.
Oh, we're missing actually one part of the example. How do you actually apply this, right? Because primitive taglet is a signature. It's not actually. Oh, you need to say this is a module type, right?
Yeah.
Equals.
Yeah.
Because this is a signature.
Yeah.
This is a functor. We
So
need
we
a
need a
name
module.
which fits
Yeah.
the signature,
Yeah. We
right?
need a module that
Here,
implements that signature.
yeah, here is where you would actually implement your interpretation of the syntax tree, right? So
Mm-hmm.
you do something like, I don't know, pretty printer. Let's just call it printer. Why not?
Uh-huh.
which is a primitive tagless, equals struct,
Uh-huh.
and
Uh-huh.
then you would define your type a wrapper. Because this is a printer, this is just a string, actually. This is not how you
Mm,
define a type, is it?
no. But what I
Ta
want to
-ta
do
-ta -ta
with
-ta.
this?
Oh, you would have to do actually implement all of those functions, right? You would have to do val,
Not val. Let.
not val, let atom
Yes.
equals.
Yes.
Actually, it would take an atom name
Which, yeah, sure.
and let's just return the name in this case, just for simplicity. Let int equals. This would have to be like string of int, right?
Sure.
Or something like that.
Okay, so the type A representation is the output type that you're gonna that you are I guess your
Yeah,
module
this.
makes sense to be. In the case of a
Yeah,
printer, is a string.
this would be the output of your interpretation, basically.
Mm-hmm.
And then the
Mm-hmm.
functions here is okay. How do you interpret this particular node of your tree, right?
Yes.
Essentially.
Yes. I see what you're doing. But that's still not that different from the tagged version. Of course, the approach is different. I'm not saying they are the same thing. One is using ADTs and the other one is using functions. But you were kind of doing the same thing of sorts, no? But you're composing the AST using functions.
Here's the point, Lemus. You can make another interpreter, which is not a printer. It could be something like, I don't know, counter. It just counts the nodes, right? Or something. And then later, you can actually take the same let. Uh,
Ah, okay. So okay, now I see why would you do this, because this allows you to have to use the line 15 sort of like a generic AST, and how you evolve the AST for your specific purpose can be like modularized.
yeah,
But
then you could do
isn't
something
just
like
that,
this.
mm, but isn't just that like having the tagged version, but then you have like different functions to quote unquote
Yeah,
evolve in different
yeah,
ways?
different. Yeah, exactly. Uh,
So that doesn't change much, right?
Um, well, there is actually one difference. You don't have to allocate the intermediate tree in the in this case, right? Because this is just a bunch of function calls, right?
mhm.
Like you don't build an AST that you then interpret with the printer. You directly print this thing here by injecting the function definitions in place of cons and int and what have you.
So the argument is like an allocation argument. You're saying that you don't have to allocate the entire tree.
That's one of the arguments. Actually, there's another argument which is it's actually easier to add an incremental to build this up incrementally, right? Because you could just say, okay, I want to make a different, um, like I want to make a different signature, uh, more primitives equals, which includes, which would include this signature
Yeah, but that
and
also
add
will be
more
the case
stuff.
with the ADT, right? You just add more tags to the ADT.
But the difference with the ADT approach is that you actually, if you do the ADT approach, you have to update every function that interprets the
Marinho,
Yes,
ADT
but that's what
if
you
you add a new
want.
are
feature.
you by any chance losing completeness with this approach?
Losing completeness, what do you mean?
Uh, Regarding it doesn't happen what you just said, right? You not get a warning bothering you to write a bunch of stuff because now there are new combinations to check on your functions.
Yeah, that's a very Marinho thing to say that he doesn't want to go back to these places and fix it. But
No, 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 no.
Nathan and
The
I, we
point
do.
is, No. The point, Lemos, is that you only have to do that if you're actually using the extensions. If you're not, you're fine.
No, but that's the thing. We want the functions that are inspecting the possibilities to break.
They don't inspect the possibilities, is the point.
No, the tagless, right?
Yeah.
Exactly. So that's that. Okay, this is a very complete makes total sense that you are a fan of this because this is the thing. This is the dynamic argument again.
No,
Right?
it's not
By
really
the way,
because
you can just use polyvars, can't you?
what do you mean?
You can use like structural sum types instead of
Yeah, polymorphic
nominal
variants. Is that what you
sum
mean?
types. Yes. So that way you have extension, right? And you also lose completeness.
You don't really lose completeness because, like, if you say, okay, I'm taking a primitive tagless here, if I add more primitives, but I don't use more primitives, then it's fine that there's no check, but also this signature prevents me from using the more primitives.
Well, not having more checks is the losing completeness part, isn't it?
No. I can't use more primitives here unless I do this. But if I do this, then I actually need to cover the cases that are here, you see?
Hmm, I'm not sure.
No, you don't have to cover, right? Because this function on line 19, because you're gonna include on line 13 primitive tagless in more primitives, this example is just fine. You don't have to touch. You don't have to do anything, right?
Yeah, if I have a functor that takes more primitives,
Yes.
right?
Yes.
I can actually pass. I can actually use the subset of it that is primitive tagless, and
Yes.
that's okay.
Yes.
Like I could pass a more primitives here in place of this m. This signature would seal that, so I actually don't have access to the more primitives, but I can reuse the actual more primitives implementation, right? And that's fine.
Yes. But
Um,
more primitives is gonna do an include of the original primitive tagless, right?
of the signature, yes,
Yeah,
it's
of
going
the
to be an
signature.
extension of
Yeah.
it.
So this program on line 19 will work even if you swap line 16.
It will actually, like, you can instantiate this with more primitives, which is fine because it includes primitives tagless, right?
Yeah. Yeah. But that's the thing. Your program, example program, will not break because it's an extension, right?
It won't, yeah.
Yeah. Yeah, but again, okay, actually now I take that back. I see the argument. The argument is that you don't want to, when you extend the stuff, you don't want to go to all the places that you're checking for all the possibilities and have to fix it. And this allows you to
If
do
they
that.
don't, yeah, if they don't actually use the new possibilities, there's no point in changing them, right?
No, I disagree with that. But okay. Because to me, if you have a piece of code that is inspecting possibilities and you introduce more possibilities and that
Lemos, but the
code
point,
doesn't scream,
Lemos, but the point is that you actually can't inspect the possibilities.
no, yes, you can't inspect the
Marinho,
possibilities in this case because they are not, how should I say this? They are
How
functions, right?
would you how would you inspect the possibilities?
No, in this case, because they are
uh,
functions, you won't, right? But in the case of the
You
literals being done with ADTs, you just can.
Well, you could implement an ADT and make that ADT implement the signature, and then Atom would turn into an actual node, just like the one we had below.
Yeah,
Like
yeah,
there's actually a
exactly.
correspondence here, right?
No, there is totally a correspondence. I see it.
oh
Like
yeah,
right here.
Ace just said it on the comments. What I was about to ask you. That's about the expression problem, right? You are just
It
going to
is,
the other way on OCaml, right? Of the
yes, it
object
is
one.
about the expression problem, indeed.
Yeah. So, yeah, it's just a trade-off, right? But yeah, I see. The completeness is not lost. It is just in a different way, right? In a different place.
Yeah, like the whole point is that you can't really inspect the possibilities here unless you make them inspectable by actually turning them into something concrete. Because up
Yes,
here they are all abstract.
yes, yes, yes. Yes, 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 yes. Okay, but now let's go back to the concrete example of uh, implementing Erlang AST. So, in your opinion, Marinho, would you say that it's a huge gain by using tagless in this case, in comparison to what Magetta proposed?
In this particular case, probably not, because the Erlang AST is very stable, right? They don't add new things all the time, and even if they do, we don't have to use it necessarily, right?
Anyway,
Well,
do we
but
have the example to generate the from the Erlang parse comments?
no, I
Uh,
don't. Well, we have that in the chat somewhere.
Yes, I we think we should
Um,
probably look
yeah, but
around.
let's say that it was not stable, Marinho. Let's say that they actually every month introduce a new node for the literals, okay?
okay.
If that was the case, would you say that, okay, we're not going to support this literal. We don't have to change this ADT, right? This type. And that's the same for the tagless, isn't it?
That is true, actually.
Yeah, so the premise that, oh, there was an extension that we don't care is true on both. No?
Well, yes, it is. In this case, it is.
Yeah, but the other premise about, okay, I want to extend something, but all the functions don't need to care about it, that is different because in the
Lemus,
ADT, go on.
the scenario is the one that you want to add it to use it somewhere else, right? But not everywhere.
Yes, exactly. That's what Marinho is proposing to use tagless, right?
What's the discussion right now? Because I
The
lost.
discussion is the following. I asked Marinho because he has to leave right now, unfortunately. I asked Marinho to explain to us what would be the version in the approach that he said it's tagless, and for him to compare with the approach that you wrote, Mageta. And he was explaining to us that essentially the tagless transforms the ADTs into functions with an opaque type, as you can see on line 2, right? So instead of having an
Yeah.
atom as a
Mhm.
as in a literal ADT, you just have the tags, quote unquote tags, as functions. So you have atom, you have int, you have new, you have cons, and then you implement an evaluator mod, a functor that you
Oh, I
pass
see.
that you pass that signature and
Yeah.
you construct your ST not by
Mhm.
using data structures but by using functions, and then you can
Yeah,
make the printer and the counter that implement the specifics of the opaque type, but your example program is kept the same regardless.
No, no, I follow.
yeah, the
Okay.
fun thing is, it turns your whole program into a functor.
That's the funny thing.
I mean, my previous implementation kinda makes that possible. So I was doing something different indeed. Uh, but you could just give a so I had
They're
I
still
had
here,
the
by the way.
let me see.
Yeah,
Yeah,
all of
this
your code is still
primitives.
here. We didn't touch it.
So what I was planning to do with it is to actually just have another
This is actually
parser.
pretty close to tagless final, by the way.
Yeah,
Well, they
exactly.
are
Yeah, it
just
kind of is, right?
so my point is like what I was thinking of this code is basically just uh why is every okay go all the way down, Marinho, please go to the yes, you see that make expression trash this builder. That's
Yeah.
why I was basically naming as functions because then I could just reuse a signature uh, to alter it with whatever way I want. I don't think it will change. Well, supposing that it doesn't change, which I don't think it will. Like the Erlang terms, right? I don't think they add new terms every day.
They don't.
They don't.
Oh,
They
by the way, they
definitely don't.
just added maybe. So
No, but
Actually, they added that a couple versions ago. It
I
was
think
in
it was
preview mode.
27. I think.
Yeah, but I
is that
think
in
it
the
actually
Beam book
became.
already? I didn't
I'm
see
not
them.
sure. Probably not.
Yeah, anyway, so Marinho, you have to go, so you don't have to commit this, although it was very educational, thank you. I think I will
I
pick
should at
this up.
least actually I should at least commit this move, right? Although you can trivially do it on your end as well.
Yeah, yeah, I can do
Oh,
it. That's
upcase.
okay. Yeah, because the project has this convention that Nathan's told us that is not a thing. Need to revert everything to lowercase. Anyway, so I can pick this up. I can
I can
pick
go
this
as well if you want me to.
up.
But well, I typed already, so just go for it.
Uh,
Good criteria. Okay, so
yeah,
what I want to do,
I'll
Mageta.
I'll still hang around in the background here. By the way, I'll just not talk probably because I need to do work stuff.
Yeah,
Have
go
fun.
for it.
Thanks.
Git
Just
fetch. I'm
listen
gonna
to the
share
Nippon
this.
Ichi soundtrack, Marinho. Not sure if Marinho heard me, but well,
Which soundtrack?
I don't know, like Nippon Ichi games soundtrack. They're all good.
To the surprise of nobody. I mean, it's the folks who did Rhapsody, so you know.
It has to be good.
Okay, so what is the name of the branch, Mageta? Erlang.
Erlang yeah, Erlango.
Yeah, the first thing I want to do is do an exhaustive check. I think like it's pretty great and impressive that you just eyeball it, but I want to go item by item.
There's a bunch of things to complete by the end, precisely. Like
Let's start by
calls,
the
they're not there.
let's start by the literals. So the first thing, I want to ditch the prefix. Can I do that?
No, man, don't do that. Don't do that. That's a huge mistake.
But we
Because
have
when you open a
modules. Come
module,
on.
man, dude,
Why would you
it's
open a module?
it's awful when you just have tags. Okay, that's my that's me. But okay, you can remove it. I hate the fact that you look at a tag like string and you don't know if it's a literal or a expression.
You
Magenta.
will
But if you
know
quali
because it's
but if you quali
primitives.
let me finish. But if you qualify everything and you commit to that, it's fine.
Okay, we will
Yes,
commit to
just
that.
retain this F sharp Magenta and you have that attribute. The what's the name of it? Do you remember? The
Attribute.
the one that makes you qualify everything.
Oh yes, required qualify. Yes,
Yes. Just
yeah,
pretend
yeah,
you have that in OCaml.
the property, right?
Yes.
I'm pretty sure you
Integer.
can do. No,
Hungarian notation for type constructors?
Okay,
I'm
then
not sure what is that.
never
unary
heard of that in my life.
operations. Let's keep this for now. Binary. We can keep that for now as
Hungarian
well.
notation for type
Oh,
constructors.
actually,
Not sure I ever
that's a
heard of
thing.
that.
Do we have a unary plus in Erlang?
Uh, I think yes. It's just let me try. No,
Because I think we
maybe
thought of
not.
Lisp, not Erlang, but I'm
Yes,
not sure.
I'm crazy. I think I'm crazy.
I'm not
Remove this.
sure.
The
I
not
mean,
these, right? But the plus
I'm
and
pretty sure there
minus.
is
Remove
actually
this.
unary plus in like JavaScript actually.
Okay.
Fix the
Yeah,
type
just
name
remove these limbs.
variables.
I have
I think I was just thinking of booleans like not,
Okay,
and
I
then a
have another
question.
question. Can OCaml distinguish this minus from this other minus? Nathan.
No, there will be a
Wait,
name
what?
collision.
Yeah.
Okay, so then there is incentive. Yeah.
Congratulations!
Then there
Congratulations!
is incentive to keep the prefixes now.
Then you do a module for unary and another
I
for
mean, at that point,
binary.
just delete the unary, right? That should not
No.
exist. The plus
Okay, but then I'm gonna
nor
delete
the
the minus
minus.
as well.
Add char and floats to that literal.
Already added.
Char and float. String. Why are you representing strings differently than bit strings? They are not the same.
But in the documentation, I'm actually gonna pull this up. Here's the documentation. So the most simplest section is this. There are 5 kinds of atomic literals, which are represented in the same way as patterns, expressions, and guards. Atom, character, float, integer, and string literal.
So when we do a bit string, does that get converted to a normal
Uh,
string?
No, that's considered a comprehension actually,
List,
because
right?
because you can do more stuff than just put a literal string inside of a binary, you know?
That makes sense. You can even pattern match things inside of a bit string. So
yeah.
I think that makes sense.
Okay, I have another question. These, what about renaming this to variable? Do you prefer var?
Yes. Yeah, no,
Because
variables
var
better.
reminds me of SQL a little bit.
Relvar. Does that remind you of SQL?
No, that reminds me of the book, so I'm pretty okay with that.
Yeah, just rename
Let's,
to variable.
yeah, but let's do the nonsense a little bit. So grab that,
I like just
there.
two software lemons.
Okay, so unary OP. So we have
These
unary
go
OP.
away.
Yeah, these go away. Oops. And then we can, that's not what I want. We can do that.
Let's complete this binary operation, and there's much more that we would want.
But we don't need these to do the programs that we could before. Anything else than these. Because before
What
we
I mean,
had
we
what?
man, there's a bunch more. There's and also where's sorry, ors, ands,
No, no, no. I'm
xors,
completely fine of making
greater than,
issues
less
so
than.
everybody can contribute with binary operators. I'm completely fine with that.
But
But I
it's cheap. You're
Uh,
already there. That's my point.
okay, which one would you put in
Lemons.
here? Yes,
At least comparisons.
Maninho.
Where we actually will need, because like we had plus and negation before, right?
Yeah.
Like that needs to compile down to Erlang's binary operations, right?
Yes.
And plus actually implies minus because we have integers.
Yes. But we already have plus and minus. But Mageta is right. We had less equals. Less
Yeah,
than or
like less
equals.
equals, not equals, difference, right? Equality,
Okay,
less than,
so
greater than
less
equal.
than equals, less, greater. What else
Can
do
you
you
just
want?
type equal?
Equal,
Like less equal, I mean, instead of
less.
like
Oh, you mean this?
the first, yeah.
This. Is that what you want?
Yeah, greater,
What
greater,
else?
equal, right? Greater, equal,
Greater, equal,
and that's it.
equal. Well, I'm gonna keep the convention, just put G here. And then we need equal. What else? What else do you want, Magita? Tell me.
Integer division?
We already have that, no?
No, that's div. That's not integer division, right?
Oh, that's not in. Okay, so
Which is stupid because in Erlang it's just truncating, so it's not
okay.
Euclidean as
What
many.
else?
And also and or else. I think those are the ones
Okay,
we would care about. There's
okay.
also the list add and list sub. I don't think we care for those now.
Or and.
Yeah, that,
Okay, this seems like enough. So we have
that's perfect.
arithmetic. That's not. Yep.
Oh, there's also the exact, so the rabbit operator.
The rabbit. Good
So
name, by the way.
it's a put the not exact as well, right? The negation.
Uh, so these would be comparisons. These is what? Ports?
Uh, well, it is not a port, it's a PID, right?
No, but this is a message passing, maybe?
Yeah, message passing. Port is for something else, I think.
Yeah, cool. So let's implement the stringification of those. There.
Probably we would want concatenation as well, no?
Concatenation of what?
Like plus plus on a
List
list.
operations.
Yeah,
Okay,
at least
so
just that.
concat. const.
Uh,
Um,
do we have cons in Erlang? Like in terms of the an operator? I don't think so.
yeah, I think I'm getting confused by the pattern
Well,
matching thing.
I
we
don't think. Yeah.
do, but it's not called cons. It's just if you type a square bracket expression pipe other expression, that's
Yeah,
your
the
cons.
pipe, but that is not. But that needs to be inside of a
Yeah, there is a special
Yeah, I
place.
don't think.
generator
Yeah,
expression,
yeah,
right?
I don't think that's a standalone operator. It's part of the list syntax.
Okay, what
Yeah.
other list thingies you want, Magita?
I think that's it.
Okay,
Just concat.
so let's put here list operations. Okay, so that's cool. Let's stringify these.
I need to copy like a clown.
Well, but that's because of the pattern matching in this case, so I think there's no really good way to do that. So is this gonna work? No.
Of course not.
Uh,
Why should that work, you silly?
yeah, I was being silly indeed. But there is a thing that I can do, which is to do this, right? So I can just say replace
Belani
string.
showed me a command in Emacs to do that. I don't remember what it is though.
But I need to skip the enter. How do I do that? Do you remember?
I think it is bar, right?
Yeah.
Like
And now I
no
need to
no
put the enter
forward
here.
slash. Yeah, okay.
Forward slash like this.
Yeah, forward slash n, I think.
Nope. You need to escape
Fantastic.
it. You need to escape it.
Yes.
But I don't
It's
remember how.
regex p. There's a syntax for that trash. I mean, just do the monkey work.
Just do the monkey. Okay. Okay, done.
Okay.
Most of those, well, some of those we have. So I'm just gonna paste them in here and delete the
The
duplicate. So
top.
plus by this double minus mult, we have it, div, ram, and
Right.
send we also already have it, so you can just delete that.
Yep.
Okay, so in Erlang, these is just div, right?
Yes. Correct.
Okay, I don't remember, but is this the
Or
language that uses these?
no, it is written or.
No, it is written. And why is it this mad? Signature
By the way, we didn't
mismatch.
put the and also nor the or else,
But
right? We
those are
just
for
have or
guards.
and
Those are for guards.
they are operators as well.
Oh, okay. So let's put
I
them.
just ignore them. Yeah, that's fine.
No, it's using more words. It's cheap.
Okay.
There. I just don't understand why.
Wait, do you put and else there?
Ah, wait. No,
It's
it's
and also.
and also. Dummy dum dum.
No, no, it's or else and also, man.
Oh, only the and.
Yes, yes.
Okay.
It's confusing.
I need to put them in there. I think I'm only gonna keep the comments up there because you're gonna be copy pasting like a monkey anyway.
Yes, sir.
So that. Now we are talking. So or, let's already put the or else
Mm-hmm.
here. Oops. Or else. So this is gonna be and also. I don't remember. Is this where is the equal? Is it here or
Everything
is
is
it here?
no wait. The last equals is the last before and then the equal after.
Okay.
Yes.
Because there was a language that pissed Marinho about it. That was the opposite, just to look ugly as fuck.
Oh, it is this.
No, no, this one I think it's the one that he's expecting. I think Marinho is not accepting this one.
No, the less than equal is on the end.
Yeah, I hope so in Erlang, right? Greater, greater that.
No, that is on the end. Is it not
Uh,
on the end?
wait, you mean the equals?
Wait, let me put the bean. Rebar 3
Yeah,
shell.
no, it's actually Erlang. For some reason, they
It is.
use equal and then the less than,
Yeah, so
which
it is
is
this, right?
which is the opposite of every other language out there for some reason.
Yes, they
And you
put
should
on the.
invert the name too, right? Equal less.
Equalize. Oh, so then I imagine that this is like that to be consistent.
It isn't actually.
Okay, so it is this.
That's the Anarchy meme, right?
Actually, I just tested here, and it is on the front always.
It is on the
No,
front
no, no,
always. The
no, no,
equals?
no, 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 no. That is right. It is at the end. That is so silly.
Maybe they have a third operator, Magit.
That is so silly. Maybe. I don't know,
What is the
Natan.
opposite of the rabbit?
It's the slash inside of the whiskers.
Like this?
Yep.
And I'm assuming this is this.
Yeah, just plus plus.
Okay, so
cool.
string of literal. Just copy these. Yeah,
Just remove the bit string then.
not a problem. Let me just a. But this is a problem, right? I need to make a string of.
Printf, sure. I think in Erlang they are with ooh. Wait, in Erlang characters are with a dollar sign.
Oh, really? So this is
That's
just
I never had to use one. So
that, like that. But I
no,
still need
that's
to
so weird.
stringify this.
Just a string of char.
String of char. Are you sure?
Wait, you are man, you are losing Julius. We're losing.
Oh. Am I back? Okay, I dropped. No route. Damn. Am I back?
You are at the server.
Hello?
Okay,
Hello?
I can hear you now.
Okay, now I'm back. Okay, my bad. Okay, so how do I convert a char to a thing?
Try see on the char module, like char capital char choose string.
Like this?
Like,
No.
I guess no.
But maybe
Ah
they're
man,
using
just
the
use
string.
printf. Just put s printf man. Printf dot s printf.
Just use as printf.
So cursed.
So
Wait, you
cursed.
don't have templates in OCaml?
I'm
We have
assuming that this is
templates.
just
Oh come on.
this.
No, no. It is an empty list, right?
Like this. Okay, now let's just figure it out how to do this properly. So
Printf
char to string.
printf
Okay.
dot. Nah, just use printf man. You need to concat anyway. String
No,
of
no, no, there
char.
is,
That
according to
actually
AI.
is
Thank you.
string. Oh, that is funny.
Make one. Thank you.
Oh, that is much worse than just using printf. Thank you.
Much worse my
That is pretty
ass.
bad.
That is horrible.
Okay, what's next? We're doing expressions. Okay, so let's go to expressions. Expressions.
Oh, that is so
First one,
cursed.
literal. Nice. So do we have that? Yes. Nice. Next, bit string comprehension,
Variables.
where
Wait,
key1 is a qualifier, then
yes,
blah blah.
that is that. That is that trash.
Yeah, but how comprehension of what? Of a string?
The comprehension is of actually characters, no?
Oh, so you receive a string like val, bit string. Oh, you have it in here, binary. Is
Well,
this what
that
you meant?
is. Oh no no no! Wait. It is a comprehension is literally just a pattern, right? So you should pick a pattern. I already Oh man, go back there. I am so smart. You see the pattern up there?
The pattern. Yes.
Ta-da! You already have the type, so just do comprehension, and then you have comprehensions for lists and binaries already. Done. Don't
Um,
put bitstring, just comprehension.
comprehension. Is that how you type
And then
that?
you're
No.
gonna take a T,
At
comprehension with an H. Comprehension, yeah. You take
H.
a T, and then you another tuple, I guess, of no, a list with tuples of patterns and T's, and then you split a T.
Wait. A list? Not.
No, no,
Let's not do that.
a T,
A
first a
T.
T, then you take a tuple with a pattern and a T. No,
That's not how you
pattern
do
and a
that.
T. Pattern is already a type.
Oh, I forgot. It's not a module.
Yes, and
And
then
this
list.
doesn't need to do that. Then
No,
a list.
no, that is a pair of lists, man. Lists.
Ah, so you mean you want
You see?
this?
Yes, and then that replies a T. That gives you back
Okay.
a T.
Okay. So next. Okay. So there apparently is
PPX
bit
for template
screen
string.
comprehension and constructor. So and that's expression.
Constructor.
Yeah.
Constructor. What does he? Let me see.
My bad.
Constructor. Wow.
Yeah.
Bitstring.
There.
If he is a bitstring constructor, that's just a constructor of a pattern. That's the same trash.
Wait. So you're saying that it's definitely not the same trash. They look different. This looks like this, and this looks like this.
One is just a binary representation of it, though.
Oh yes, but I'm just making the argument that they are different, so we should treat them differently.
Yes, we should have a binary. That's my point.
Okay, so binary is something that does what?
T. That's it.
Okay. Next is the block. So where is the block?
A
Here.
block is just a T list to T.
Then a case.
Case will be T with clauses, I think. Clause
Wait,
list
use an
to T.
expression is a case clause. It's a list of things,
Yes.
no?
Yes, clauses. So T, clause list, T. The same for the receive, by the way. Actually, the receive you don't have the first T. You just have the
Wait,
clause
I
list
don't. Okay, but
to
here's a hot take. I don't want to support this. I think.
try catches.
Yeah, are we gonna support that for
Uh,
now?
We're
no.
gonna need that even if we don't support it in Karuta, because that's how we're gonna implement.
Oh yes, backtracking, I guess, right? Oh no,
Okay, so
Actually,
backtracking is for something.
it's
actually,
just a T,
Oh,
technically,
right?
we
we
might.
Go
technically we
on.
can implement backtracking in terms of maybes as well.
Maybes.
Yeah, which is treating errors as
Oh yes,
values.
but I think the point is valid, right? This is not what we are going to use on Karuta, but like exposed to the language, but we might implement features from Karuta with the features in Erlang, right?
Yes,
That are
yes. This
done.
is just for completeness sake. But is this just a T? Because look at it.
Catch. Catch I think is T to T, right?
Okay. Okay, next one is the cons, skeleton. Okay,
Cons I think it would be
two things, no?
cons, cons,
Double.
cons. Yeah, just three, right? So T to T to T.
Oh, you could make these a tuple, but I like your
Yeah, but
current version.
that yeah, that
The
mm,
next one is okay. Now we're going to the functions that we skipped before. So we have function number one, which I don't know how we're gonna call it, but it's when you're using
f-
in a high order function.
so function expression, I assume.
Yeah, no, but
Oh no,
all of them are
sorry.
function expressions.
That is an okay. So there is the named function, right?
Okay,
There's
that's a
the
good name.
lambda.
Name fun named. So this is
Yeah, so that would take a type a var, like a primitive variable, primitives
primitives
variable,
variable.
a clause list, right? And then a T. And then the
Wait,
lambda,
I'm talking about this one though.
yes, that is a named function.
Yeah, but
Name
that
arity, blah
yeah,
blah.
but then you don't need the clauses in this case.
Well, it has guards, right?
Has guards.
Yeah, functions have guards.
No, man. I think I'm didn't communicate properly. You know when you do this in Erlang and you do fun something that I think this is this.
That is not a named function, right? That is the definition of a function with its body, no?
Oh, you think it's
It's an
that?
expression.
But where
Otherwise,
is
it's just an atom.
yeah? But where
That
is
is
the
just an
body
atom.
coming from in this case? You only have a
So
name and
that
an
is a
arity.
fun annotation. Well, the body is inside of these, no?
No, I think the one that you're
Isn't that
talking about.
subsequent? Let's compile one right now.
Sure. Um
Where's the? I sent the
Earl.
code on the
I do have it.
trash. I think it will be with a tuple inside of the other tuple expanding.
Okay. But
Oh,
here's the thing. Here's the thing. So let me copy paste there. So I don't want this actually. I want lists map. Uh, Marinho, what is the name of the identity function? Do you remember?
What is the name of the identity function? Not really, no.
Uh, okay, so before that, let's define a thing. So
of
identity.
course, I cannot have that as a functional declaration. I was thinking that would be a declaration, right? But I don't think.
I don't think it is. In that this is I'm tired. Identity.
Well, you can have guards on that thing too, I assume. But
Okay,
the
so lists
expression.
map fun identity one. I want to know what this is. So there. Now let's say that you
Oh,
want
that is a
one,
call.
two, three. So this is
I forgot the. You forgot the comma. Alright.
Yeah, this is not ML, Lemus. Neither is it Haskell. This is Erlang.
yeah, but I don't
No,
remember how
man.
to
Like
do
you
the
keep.
lists anymore.
No, you keep your com. No, man, dude. You keep the commas. You just need the parentheses on the function.
I need parentheses on the function. Oh,
Map has two
here.
arguments.
You mean here?
This is not a Lisp, Lemus.
Yeah, no. Too many languages for me to deal with. Okay, this
No,
should work.
man.
Okay, okay.
That
Now we parse the tokens, right? So parse this.
man, that is not correct. You're forgetting the comma
I'm forgetting the comma here. Where?
and another parenthesis. Man, it's a function. You need to apply with two things, right?
But I
You're
have two
currying
things.
them.
I have this thing and I have this thing.
You are treating it as Haskell, man. It's not like that. It's like fun
Ah, I forgot.
is the first argument.
I
Yes,
forgot.
yes.
I just forgot.
You're crazy, man. I think you have unbalanced parentheses, no?
Do I?
No, that looks correct.
No, but I don't need these, right?
Yeah, that looks fine.
This is
You
fine
don't
now,
need the
right?
fun. You don't need this fun, by the way. But
No,
okay.
no. I do need it because I'm speculating that this is what the documentation is mentioning.
Okay,
But
try.
it's still fucked. No match of right hand
Oh,
side
because
variable.
because you're already assigned to that variable, right?
You
So
gotta be.
just put tokens two, and ignore the end location.
Okay.
And okay,
True. Go. Syntax error.
remove the fun and the slash one.
So you think it's like this?
No, that is exactly how you do it.
I don't think that's how you do it, but let's see. Nope. We don't know Erlang anymore. We did too much LFA. We are confused. I'm gonna stop the recording because it's already
Lists
2
map.
hours.